Karl, I learn something new every time I come to one of Open Minds events. We're here at Training 2000 today in Blackburn. What are you actually showing here?
There's two areas that we're showing. One is like you said, the MAXX Machining, but we're also showing the use of the barrel tools, which allows us to save a lot more time with different and newer strategies that are just now available.
And barrel tools are just for the finishing process, are they?
Correct, yes. But what it allows us to do is get into tricky areas where, like deep pockets with tight corner radiuses. It also allows us to improve the step down, and the finish is improved, and also the massive time savings because the curvature on the side of the barrel tools allows a larger step down as opposed to scanning.
And what about roughing as well? Roughing represents around about 30%, doesn't it, of your machining strategy or cycle? Yeah. So is there improvements there too?
There's only so many improvements you can make. Like you said, it's 30% of the time in the roughing. So we're down to, with the tooling available, either going faster or faster speeds, faster feeds. But now I think what's happening is the trend is now moving over where can we make the changes now in finishing as well.
Is there any compromise in using this process? I mean, for example, things like tool wear and also wear on the machine. I mean, are you pushing the machine that much harder? I
don't think we're pushing the machine too hard. I think we probably demand faster axis movement more than anything. So there are limitations if the machine can't handle the speeds that we're now looking for the finishing.
Adrian also mentioned in his presentation about 5-axis drilling. Seems a strange name. What does it mean, 5-axis drilling?
5-axis drilling is a method of clearing out a lot of material very quickly. So what we're doing is we're tilting the tool over on an angle and doing a helical cut right down from top to bottom, which allows the load to be reduced because now we're not doing a full cut. We're tilted on the side, and also the clearance at the back means we're not
Does it mean you can also use them one tool for various size diameters?
Exactly. So you could go right from the helical drilling operation straight into a constant Z operation where we're doing Z level cutting down the sidewalls with the same tool.
And how do you maintain accuracy using that method? Is it down to the machine or the software or both?
I think a combination of everything that's available to you. You're working with the tolerances on the machine, how fast the machine can run, and also the spindle power that you have to allow us to kind of drive that tool we want to go with a really sharp, really deep helix, like a sharp angle.
Coming back to the barrel cutters, how do you maintain a good surface finish when you're machining so quickly?
The secret's in the radius on the side of the tool. So instead of using a small radius and stepping down like a scanning operation where it takes a small movement, it takes a lot of movements to kind of give you this finish, you can now drop down a larger step down and maintain an even better finish in some cases.
And does the tooling last a long time?
It seems to be, because with less cutting, less wear and tear on the tool. So it seems that the tools that we've been using in our demonstrations have been, we haven't actually changed the tools yet.
And tell us about this part quickly. Tell us about what we're seeing here.
So what we're seeing is where we're able to utilize the barrel tools to reach deep cavities with tight radiuses. So in this case, it's a 3mm radius, but we're like 46 millimeters deep, so it's over 10 times the diameter of the tool, and which would then, would create problems if we were doing a scanning operation.
How are you roughing that out?
We're roughing that out using the tricordial cutting, the MAXX Machining. So what we're doing is we're approaching it with a helical drilling operation to open up the cavity. We then move into a constant Z level cutting, so where we're stepping down and with the tool, and then we're doing some swerve cutting to take us closer to the size, and then we finish off with the barrel tools.
What about the second operation?
So the second operation is based on this side here. So what we're doing again is we're using the tricordial cutting in a 5-axis motion. So we're actually this is a radius face on here. So we're actually concerned of the roughing out to the fit radius as well as the blade. And then we move into a tricordial cutting around the side. And then we're finishing again using the barrel tools to finish with a constant Z level and a spiral helix down the blade.
How many different tools are used throughout the manufacture of this?
In total, 4.
Okay, and talking about the whole process of MAXX Machining, we talk about reducing cycle times, we talk about having better surface finishes, we talk about longer tool life. What's the catch?
I'm not sure there is a catch. I think the the quality is being shown with the through the presentations, and the times are being reduced, and the tools that like you said earlier on, the tools, we're actually only using 4 tools in this whole process from start to finish.
And Adrian always mentions, and he always says in his presentations about MAXX Machining and this type of machining strategy being the next 5-axis kind of revolution. Would you agree with him?
I would, yes. I mean, I'm actually new to only 1 year with the hyperMill, and I'm blown away with the capabilities of the software.
And is there like a rule book as well on what machine can actually achieve this? You know, it doesn't. You surely can't. No, not every 5-axis machine can be able to do what we're seeing here.
I think if you have the 5-axis machines, you've got more capabilities of how you approach it. But even on this side, we show that if it's just a 3+2 where we're rotating and locking a position, we're still able to keep the finish the same and the times down.
And with this machine here and the way you're doing this with the 2 operations, would you have not been better to put one part in the middle and finish almost all the component and then take it off and do the second op somewhere else? Wouldn't it have been better on the machine for its kinematics and its movements?
I think for the finishing, yeah, I think you could still maintain some maybe a little bit better quality if it was in the middle. But I think we're trying to show off the flexibility of the machine in the abilities to do more than one operation and spread that across the same table without minimum setup.
Cycle time of this part?
Cycle time is about 1 hour.